Good morning, friends. I feel immense pleasure to be here again for my course, Engineering Thermodynamics. I have started my last module, 5th, and this is my second lecture of my last module. In the previous lecture, I have discussed about the heat transfer rate, Fourier's equation, one numericals we have solved. Today I am going to discuss about types of heat transfer. And in this, we will be discussing some more detail about the heat transfer. In the previous class, we have just given introduction to the heat transfer, and we will see here what we are going to see in today's class. So, here we will see the heat transfer and the driving force, important transport processes, objective of this module, definition of heat transfer, phases of heat transfer. In this we will see the multi-phase, phase change, then modes of the heat transfer. We will see the conduction, convection, radiation. Then we will see the next term is thermal diffusivity, and in the phase we will see the one phase, multi-phase and the phase change. These are the some topics which I am going to take in my today's lecture. Heat transfer and the driving force. We have seen that if the temperature of any slab, you supply some heat and the temperature of one surface is raised, this due to vibration and the lattice wave or the electronic transfer of energy will take place, and due to this the heat will move from, or the temperature of this system will go from high to low, and heat will move from high temperature to low temperature side. So we are going to discuss about heat transfer and what forces it to move from high temperature to low temperature, that we are going to discuss in today's class. So what is the transfer? First we have to, because it is a heat transfer, so first we should know what is the meaning of heat transfer. So heat transfer meaning movement of certain quantities due to interaction of the system with surrounding. Any certain quantity, it may be work, it may be heat, or any property of the thermodynamic property, if it moves from one point to the another, or it moves from the system to the surrounding, then we say that transfer is taking place. So it is a movement of certain quantities. These quantities may be heat, may be work, enthalpy, entropy, temperature, pressure, and so many things. So if it is interacting with system and the surrounding, and the movement is taking place, then we can say that it is a transferring. The quantity is transferring. And if we are transferring the heat, then we can say that it is a heat transfer. So what is the driving force? Next, we have to see that what is making that it is transferring from one point to the another point. So what is that force? That is called the driving force. For heat transfer, it is a delta T. So if it is the heat transfer, it is a temperature difference. Then only the heat transfer will take place. So it is called delta T. So temperature difference will make the system to transfer the heat from one place to the another place. For mass transfer, it is a delta mu. So if it is a mass transfer, it is a difference in its property. It is called the delta mu. So types of driving forces. So how many types of driving forces are persisting, that we will see here. We have one naturally, and another is engineered. Means natural driving force is there, like in atmosphere, your wind is coming, your cyclones are coming. Some naturally it is occurring, and wind will flow from one place to the another. Heat will also from one part to the another. Engineer means it is created by the human being, and that type of, it is called the force also. Somebody will say that it is a forced driving force. So important transport processes. So we have to see some important driving processes, and they are the mass transport, momentum transport, and the heat transport. So we have the three different transport processes. One is the mass transport. Mass is transferred from system surrounding or surrounding to the system, and the moment transfer from system to surrounding and the surrounding to the system. And same way, heat also is energy. Heat is also energy. So energy transfer from system to surrounding or from surrounding to the system. So we have these three important transport processes. So objective and definition of the heat transfer. So why we study this thing, and this we will be seeing here. So objectives are to quantify the heat transfer processes in various systems. So that is our objective of this study. Looking various terminologies, we will be studying different terminology of the heat transfer, physical principles involved in heat transfer phenomena in various systems of the interest, writing models of the heat transfer. This models means mathematical model of the heat transfer. Then local and the global heat transfer coefficients. Like we have just seen the K, then H, and there are so many other heat transfer coefficient will be coming in picture that we have to study about that. Analyze the model and the behavior of each of them. Now so these are the objectives which we will be undertaking in our next classes, but these things we will be discussing. Now the definition of the heat transfer. It involves generation, use, conversion and exchange of thermal energy, that is heat flow between physical system. So either it is generation, use, conversion and exchange of thermal energy, that is the heat flow between physical system. For example, it is cooling of the fluids, liquids used in power plants, chemical industries, process industries and so on. So the heat transfer means it is generation, use and the conversion and exchange of thermal energy from low to high or high to low. It may be for the cooling of the fluids or liquid in the power plant. You might have seen the heat exchanger, chemical industries, process industries and so on. To find cost and efficiency of the thermal system. So this is also our objective, to find how much cost. We have seen one numerical in my previous, that how much rupees to cool one house. That I have discussed. So we can also find the cost, and so we will see here that some phases of the heat transfer. So we have the one phase, then multiple phase, then we have the phase change, that is water heating, then boiling and so on. We will be discussing about one by one. So here we will see the first one. So one phase heat transfer, multi-phase heat transfer and phase change. So first one is the one phase, it is a solid. This is the slab here. So the heat is transferring from phase, this is the S1, I am writing surface 1 and the surface 2. The temperature of this is T1 and this S2 is T2, and transfer is taking place from T1 to T2 as T1 is greater than T2. It is called the one phase heat transfer. In this one phase heat transfer, the heat will be going from high temperature to the low temperature, and it is dependent upon the conductivity K and the perpendicular area. So this area is always taken perpendicular like this. So if you see this area, we will be taking this length will not be added, for it is X and this is the A. So we have seen that Q is equal to minus Ka dt by dx. So this is the X and this is the A. Second one is the multi-phase heat transfer. So in this is the solid phase, solid slab, and here is some hot liquid and here is some cold gas. So this heat will transfer from here to here to the solid, and from the solid it will go to the gas. So it is called the multi-phase. So hot, it may be liquid, then it is a solid, then it can go to the air or the any gas. So this is called the multi-phase heat transfer. Next we can see the phase change. So in the phase change, if you see like our refrigerator. In the refrigerator we have some refrigerant. Refrigerant normally found in a liquid form, and if we boil this liquid, it will nucleate and then it will vaporized. So here steam, or if you can see the water in the liquid, water is entering and it is moving like this, and here it will become steam and it is heated by the boiler. Heating is taking place by the boiler. So this liquid is converted to the vapor, and it can also be from ice to water and from water to the vapor. So like this, the different phases are there, and so one phase, multi-phase, and phase change from water heating to boiling to nucleation and the vapor phase, and these all three phases are shown in this three diagram very much clearly. So it is a one phase heat transfer, multi-phase heat transfer, and this is the phase change heat transfer. So these are the three types of heat transfer, and it is called the phases of the heat transfer. Now we will be discussing about modes of heat transfer, and we have discussed in my first lecture of heat transfer that we have the three modes of the heat transfer. That is, A is a conduction, then B is a convection, and third is the thermal radiation. So I will discuss about the conduction, and this conduction mostly happens in the solid and also in the liquids, but solid is more prominent. And if the surface of the temperature, this surface is T1 and exit is T2, and if T1 is greater than the T2, so this solid will transfer heat from T1 to T2, and this method is called, and it is happening due to the two ways. First one is by the lattice wave method, and another is electron movement. In this, only vibrations of the molecules will take place. Molecules will not move from its original position. As you give the extra heat or any energy, this will vibrate. The molecules will start vibrating, and this vibrating molecule will transfer the energy from one to another place. Then we have the convection. In this convection, there is a solid and there is a liquid. So if the heat transfer occurs through stationary medium, that is the solid and the liquid, such kind of energy flow is known as the conduction. And if you see here, Ts is greater than the Tf, means the temperature of this solid is greater than the temperature of the fluid. So your heat transfer will be in this direction. And if Ts is greater than the Tf, the flow of energy from solid to liquid, such kind of heat transfer is known as the convection. So from solid to liquid or liquid to solid, whatever is there, this type of transfer is called the convection. Another is very important here. Here we have one source here. Both are not connected. There is no medium. But if one body has the temperature T1, another has the temperature T2, and if T1 is greater than the T2, so this energy will transfer from this side. Exchange of heat due to the electromagnetic waves, medium not required like sun, fire, etc. So like we are getting the heat from the sun. So it is coming from so much distance, it is not directly, it is as and when it is hitting the surface, that surface will get heated. So it is due to the electromagnetic wave, and that is why this is called the thermal radiation. So we have the three types of modes of heat transfer, that is the conduction, convection, and the thermal radiation, and all these three types of these things are explained here very well. Now I will discuss further about in detail about the conduction process, because this is the first process and which is happening in the solids. So transfer of heat from the more energetic to the less energetic particle of a substance due to interaction between the particles moving randomly is known as the conduction. So, transfer of energy from the more energetic to the less energetic particles of a substance due to interaction between the particles moving randomly is known as the conduction. So, here the higher temperature, if the temperature is high, the molecular energy of that system will be high. So, in this way, it is vibrating, the system is vibrating, and you are going to get the conduction. This occurs due to the collision. Energy transfer take place towards the particle having lower energy. High temperature take place due to the temperature gradient is present, that is called the delta T. So it is happening due to the temperature gradient, and it is happening due to the collision of the molecules. Energy transfer must occur in the direction of decreasing temperature. Very important. So, energy transfer must occur in the direction of decreasing temperature. The direction is crucial for quantifying the heat transfer. It is very much essential that you should find out which direction the temperature will move or the heat transfer will be there, and it is always from high temperature to the low temperature zone. Thermal diffusivity. Now we have to see another term that is called the thermal diffusivity. In solids and the liquids, this occur due to the molecular interaction. This is happening in the solid and the liquid, and it is due to the molecular interaction. Non-conductor transfer occurs due to the lattice wave. In solids and the liquid, it is due to the molecular interaction. Molecular will interact, but if it is a non-conductor, it is happening due to the lattice wave. And in the conductor, governed by the translational motion of the electron. Very much essential to understand that in a non-conductor, lattice wave is very important phenomena, and in the conductor, it is motion of the electron. Electron will move. So this we have to take very much careful observation that lattice wave is a wave which is by its vibration, it is transferring the energy. But for the electron will transfer to the another electron, and in this way transfer of energy will take place. Thermal diffusivity differs for different materials. So this like conductivity, diffusivity also differs for the different materials. Okay, next topic we will see the quantitation of thermal diffusion. We have seen in our previous lecture that about thermal conductivity. Now we will see another term which is called the diffusivity. So rate equation. So what is the rate equation? We need to find heat transfer rate due to the conduction process. We have to get governing equation for rate of heat transfer. We have seen in previous lecture also the Fourier's law of heat transfer. This law relates the heat transfer rate with the temperature. Okay, so we have seen that heat transfer occurs at decreasing temperature, means high to low temperature. And what is the flux? Flux is per unit area, heat transfer per unit area. So this flux Q double dot is directly proportional to minus dt by dx. Minus dt by dx. Let us take a slab with the area A, where in this area is A, this is the area where, and the temperature of this 1 and 2 is T1 and the T2. T1 is greater than the T2. So at x is equal to 0, it is the Q double dot x, it is called the flux. So Q double dot is equal to flux, and Q is a rate of heat transfer. So from the Fourier's law, Q double prime is equal to minus K dt by dx. Now for area A, the heat transfer rate Q is equal to Q double dot into A. So it will be minus Ka dt by dx. So heat transfer rate Q is equal to minus Ka dt by dx, and this is called the Fourier's law. So here we can see that Q is directly proportional to the A, Q is also directly proportional to the dt by dx, or it is the rate of change of temperature, and Q is also directly proportional to the K, and this K is a thermal conductivity. K is what? It is a thermal conductivity. So now we will see that units of flux Q double prime is equal to watt per meter square. Rate of heat transfer Q is equal to watt joule per second. So we can see here that Q is equal to minus Ka dt by Tx. K is a thermal conductivity. So this watt is equal to K, A is equal to meter square, dt is equal to Kelvin, dx is equal to meter. So K is equal to watt per meter Kelvin. So this is the unit of thermal conductivity. So unit of thermal conductivity K is watt per meter Kelvin. So this we have to remember, that unit, it is very much essential. For non-isotropic material, Q double prime is equal to minus K del T. So what is this del? So minus K, it is the I del T by del X plus J del T by del Y plus K del T by del Z, where we can write this flux is equal to I Q double prime X plus J Q double prime Y plus K Q double prime Z, where T is equal to function of XYZ, where XYZ is the position. So here Q double prime is a function of temperature, and so this is the function of XYZ. So now thermal conductivity. What is the thermal conductivity? Thermal conductivity is the property to conduct heat. The value for gas, liquid and the solids are having much difference. So this thermal conductivity K solid is much greater than the K liquid, and the liquid and the solids are much greater than the thermal conductivity of the gas. So in which range the thermal conductivity fall? For the gas it is very less, 0.01 to 0.1 watt per meter Kelvin. For the liquid it is 0.2 to 5 watt per meter Kelvin, and for the solid it is above 10 watt per meter Kelvin. And we have seen for the diamond it is 2300 watt per meter Kelvin. So diamond has got the highest thermal conductivity. So in solid, K is very high due to the molecular and moleculars are packed tightly. So the conductivity is higher in solids than the liquid and the gas. This conductivity K is equal to Ke plus Kl, where E stands for the electron movement and L indicates for the lattice wave. So we can see that for the metal, K is very high and then the Kl. So Ke is greater than the Kl. So K is equal to Ke is equal to 1 by rho E, and where rho E is a electrical resistance. So it is inversely proportional to the electrical resistance for the solids. For non-metallic like ceramics, Ke is less than the Kl. So Kl is a lattice wave. So for K of the quartz is greater than the K of the graphite. So this we can see that for the non-metal, like quartz and the graphite and all, here lattice waves are important. Conductivity of a fluid and the gases. So how we can see that in fluids and gases how the conductivity is taking place. Fluids particles are more random, therefore conductivity of the liquids are less than the solid. So K liquid is less than the K solid. K gas is less than the K liquid and it is less than the K solid. Conductivity of the gas depends on the temperature, pressure and the chemical composition. K gas is directly proportional to eta C bar into lambda, where eta is equal to molecular number, C bar is equal to average velocity of material, and lambda is equal to mean free path. So this is the equation by which we can find out that the gas conductivity of the gases depend upon the molecular number, velocity of the molecules, and the lambda is mean free path between the molecules, by which we can find out the conductivity of the gases. Thermal diffusivity. Okay, we will discuss one more term which is called alpha. It is very, very important. So thermal diffusivity is the thermal conductivity divided by density and the specific heat capacity at constant pressure. So at constant pressure, if we divide the thermal conductivity by the density and the thermal capacity or heat capacity, it measures the ability of a material to conduct thermal energy relative to the ability to store thermal energy. High diffusivity means heat transfer rate high or rapid transfer of heat. So that is this alpha, that is called the diffusivity, is equal to K by rho Cp, where K is the thermal conductivity, rho is the density of the material, and Cp is the specific heat of the coefficient for the at constant pressure. So this unit of the alpha, we know that unit of the K is watt per meter Kelvin and rho is equal to kg per meter cube and Cp is equal to joule per kg Kelvin. So here we can write joule per second meter Kelvin divided by kg per meter cube, joule per kg Kelvin. So Kelvin, kg, 1 meter to 1 meter, here is square. So here we will get that joule and joule. So only S and meter square. So we will get meter square per second. It is a second. So this is the unit for the diffusivity is meter square per second. So unit of the thermal diffusivity is alpha is equal to meter square per second. So area divided by time. So this is the unit for the thermal diffusivity. So okay, next class I am going to discuss about these topics. Okay, it is not there. These are the references which I am going to take. That is the P.K. Nog, Engineering Thermodynamics, Tata McGraw-Hill's 4th edition. Eunice Senegal, Michael A. Bowles, Thermodynamics and Engineering Approach, Tata McGraw-Hill's. Any questions you are welcome to ask. My email is ydvedi@gmail.com. Please do like and subscribe my channel. Also give the comment. It will be enhancing my capacity. Also I will get boosted. Anywhere you want further clarification, you can send mail to me. Thank you very much. I will be replying your all the mail till that time. Thank you very much, and we will see you again for my next lecture about heat transfer.
Like, share and subscribe. Hit the bell icon for more updates.